Hello and welcome. I'm Charles Crichton, representing the Student Design Competition Gold Team from the University of Central Florida's ASME chapter. We are a group of 16 individuals, primarily consisting of freshmen and sophomore students. As you all know, this year's challenge, titled Building to the Sky, tasked us with creating a device that can manufacture a paper tower that would compete in strength, height, and speed rounds. For this competition, we designed a device lovingly named Charles and the Paper Factory. To come up with our design, we started by figuring out what kind of paper tower would be the most structurally sound. After testing different shapes, we determined that cylinders held up the best against different loads of weight when compared to other shapes like triangles and squares. We also knew that the tower design would need to be manufactured quickly and feasibly. As a result, a simplistic design using a minimal paper per layer ratio was needed. From this, we determined the design consisting of 4 cylinders layered with a horizontal sheet to be the best for our paper tower. With our ambitions and a solid plan in sight, we started the process of designing our robot. First, we developed a function and component decomposition to create a layout of what our robot would need. From this, we determined that our robot would require 3 main mechanisms. First, it would need an intake to take the paper into the robot. It would then need a mechanism to turn the sheets of paper into cylinders. And lastly, due to the height constraint, it would need a lift in order to raise the tower above the robot. We then split up into 4 sub-teams: the intake team, column team, lift team, and programming electronics team. Our creatively named teams first created basic sketches of components needed, before developing computer-aided designs using Fusion 360 to further model the mechanisms. Afterwards, we started the production of prototypes for each of these. Now we're going to go into more detail on the specific mechanisms, starting with the intake team.
I, John B., am representing the intake team. Our design feeds paper one at a time into a single opening and then transports the paper to both column systems. An intake with a single entrance makes the input of paper by a human more efficient, as well as staying within the volumetric restrictions. The team decided to create this V-shaped design with 4 rubber flex wheels which can drive the paper through both channels. An actuated dispensing system sends the paper to the left or right columns.
I'm Jack, representing the column team. The column team was tasked with moving the paper fed from the intake system to its final position on top of the lift platform. We designed a system of channels using rubber flex wheels to push the paper forward and actuators to move the paper into the rollers. The rollers are composed of 2 circular doors that open once the paper column is finished rolling and allow the entire column mechanism to be moved outward to clear space for the lift system. The base of the robot is also included in this design and uses a gear and rack system to slide the column mechanism outward.
Hello, I, Ricardo, am representing the lift team. The final design of the lift was no easy task. After countless iterations and various concepts and ideas, we settled on a driveline-inspired lift. Powered by a powerful NEMA 17 motor, we ran 4 gears up 4 racks. The idea was to assemble each layer of the tower on top of it, and then run the lift frequently up and down, adding layer by layer, and then finally resting to hold up the weight of the entire tower.
I'm Kurt, and I'm representing our programming and electrical team. We chose to use an Arduino to control the robot, and to simplify programming, we abstracted all the robot's physical components into an object-oriented API. This lets us keep our programming compact and easy to read, which aids collaboration between team members. The robot has multiple light sensors distributed throughout it, which help it keep track of where each paper is, so the rollers and elevators can activate when needed, saving us time on each run.
Due to many of our parts being manufactured through 3D printing, there was an incentive for us to do as much of our testing and redesign digitally. Luckily, utilizing Fusion 360's advanced simulation tools, our team was able to test stresses on our design and determine if it could withstand them. This was especially useful with the lift mechanism, which had to hold up to 15 pounds during the weight round. Fusion made it easy for us to conduct our simulations and make changes and redesigns in the same software. Throughout our design process, we found that it was most beneficial to anticipate possible problems and develop solutions preemptively. One such problem was the issue of paper losing its cylindrical shape, which we remedied by designing a paper stapler to fasten the paper cylinders to a fixed radius. We also developed plans to create a protective roof over the entire robot to protect it from any damage caused by falling weights. Though we were unable to complete the entire robot, many of its systems and parts were able to be tested independently. Our tower itself would have taken an estimated 2.5 minutes to be constructed to a height of 1.5 meters. Throughout early trials, we also found that our tower design could hold at least 10 pounds of weight. Throughout our manufacturing process, we tested the movement of the paper through our mechanisms and made adjustments according to how smoothly the paper went through the channels. How tight to roll the paper columns was also a point of contention within our team, and our trials found that rolling the paper tightly and allowing it to spread out increased the contact between the columns and the horizontal paper layers, which allowed for greater weight to be held over a greater surface area.
And that's our project. While we weren't able to finish our final product due to the COVID-19 pandemic, our professional design process and use of CAD software earned us the sponsorship from Autodesk and allowed us to create an effective design. Everyone here in the SDC Gold Team learned a lot along the way and had a ton of fun doing so as we charged on. From all of us, thanks for listening to our presentation.